The amplifier's output is transformer coupled to a display, which is basically, this display is right here and it's acting as a load and has an internal resistance of 15 ohm. Voltages and currents are RMS values. So we have the current given here, which is, this is the maximum current, 187.5 milliamps. This goes in here. You have a 90 ohm resistor over here, and so this is the impedance of the primary side of the transformer. This is the impedance at the secondary side of the transformer. You get the turns and you have the primary current flowing into the transformer, and what comes out of the transformer is your IS, which is the secondary current of the transformer. If the N1 to N2 turns ratio of transformer is 3:1, with Imax being 187.5 milliamp, we have to find out the minimum power rating of this circuit, right? Which is simply just going to be a product of V of A. It's expressed in volt amps. So if we can find out VP here, and if we can find out IP, we can take a product to find out the minimum volt amp reading of the transformer, correct? Now, how do we go about solving something like this? Now, remember, we know that the ratio of the primary impedance and the secondary impedance is always equals to square of N1 over N2. Now, because N1 and N2 is given 3:1, so if I plug in the value here, 3:1, and take a square, I basically get 9 here, correct? Now, from this equation right here, I can transform that into ZP equals to 9 times ZS. And because ZS is just simply 15 ohm, which is given here, correct? If I take the product 9 times 15, that basically gives me 135 ohms. This is the primary impedance, correct? Now that I have the primary impedance, I can find out the primary current, right? How am I going to do that? Well, I can just simply apply a current divider. Remember, IP is over here, and the current divider equation says the primary current equals to the maximum current, which is 187.5 milliamps times 90 ohm divided by the sum of the two resistance. The two resistance are 90 ohms plus the primary impedance of the transformer, which we just calculated, and it came out to be 135, right? Remember, these two are in parallel, right? So when we apply current divider, we can measure the primary current by plugging in the numbers in this equation, and we basically get what? We get 75 milliamp, which is the primary current, 75 milliamp. Now, if it is not being asked here, but if we need to find out the output voltage on the secondary side of the transformer, it's just simply going to be an Ohm's law, IS times the resistance, which is 15 ohm given. Now, at this point, we don't know what IS, but we should be able, by the end of this problem, be able to find out IS. But again, it is not being asked, so we are not going to worry about it. But I just wanted to put the equation over here. Next goal is to find out how much of the current is flowing through this 90 ohm resistor, right? Because we have 187 milliamps coming here, 187 milliamp coming over here, we know the current that is flowing over here. If we can subtract this current from the total current, we can find out the current that's flowing into 90 ohm resistor, right? And therefore the equation becomes the current flowing in 90 ohm resistor is equal to the maximum current minus the primary current. And if you plug in the values, we basically get what? 187.5 milliamp minus 75 milliamp, and that gives us 112.5 milliamp. 112.5 10.5 milliamps. We need to find out the primary voltage now, correct? The primary voltage is basically the voltage across this 90 ohm, correct? Now that we know the current, we can just simply apply Ohm's law to find out the voltage across 90 ohm. This part we just calculated. Resistance is known 90. So 112.5 milliamp times 90, and you do the math here, you basically get 10.125 volts. Okay, this equation and the above equation are just basically similar, same. There's nothing different about it. Now that I have calculated Vp and I have already calculated Ip, I can take the product of the two to find out the minimum rating of this transformer. Vp is 10.125, Ip is 112.5 milliamps, and if you can put it in brackets if I like. If I do the math, I basically get power equals to 0.7594 volt amp. This is important. These units are important. Volt amp. Pretty simple, right? This is a very common question to come in a PE or FE exam.